We begin with the fossil fuel sector. This sector contains one of our abatement strategies concerning fossil fuel production. Even though there is not much to it, it is very important in calculating the dissolved organic carbon and the amount of fossil fuels produced, both of which are used as ghost variables in the rest of the model you will see. Moving on, we have the land sector, which contains two abatement strategies concerning tilled land and reforestation. It also contains the fires variable, which calculates how much carbon is released through fires. Shown, we have the ghosted variable biomass from the main model. Next, we have our water sector. In the shown circle, we have an instance of randomness. It calculates random temperatures and shows the effect on marine life. We also have ghosted variables from the main model and the fossil fuel sector. This sector also calculates the surface sediment variable, which is used in the main model to help calculate the flow from the upper ocean to the atmosphere, as we will show. Integrating all of the sectors, we get the major part of the model. Here, we have also included a volcanic disturbance which can be turned on and off in the interface. Shown by the three green arrows, we have all the variables that are ghosted from the land sector. These are all used to calculate the flows to which they are connected. The next arrow shows the stock ghosted from the fossil fuel sector, which with emissions rate calculates the flow of anthropogenic emissions. And last, we have the surface sediment variable, which is ghosted from the water sector.
Our team has implemented 3 abatement strategies to resourcefully reduce atmospheric carbon levels. Our first abatement strategy focuses on the reduction of global deforestation and an increase in both afforestation and reforestation efforts. The replenishment of global forests is essential to increase the capacity of carbon sinks on the planet. A reduction in the practice of till farming in favor of no-till farming also aids in this notion. No-till farming aims to leave farmland relatively undisturbed throughout the crop growing process, allowing the soil to not only sequester carbon but hold it below the surface for long periods of time. Anthropogenic emissions and reduction in the production of fossil fuels is the most drastic abatement strategy our team has put to use. Humans hold stringent control over both of these sources of carbon, allowing for the possibility of maximum reduction of these two sources through a fundamental shift in our actions. Our other 2 abatement strategies work together with this reduction in emissions to cause an initial lowering of atmospheric carbon and continue the decreasing trend into the next 100 years.
This sensitivity analysis shows us projected outcomes in the next 100 years, the blue projecting current trends and the red implementing abatement strategies. Variables supporting this are shown at the bottom of the slide. In the suggested rates graph line, a slight increase after 55 years can be seen due to the strategies reaching their peak effect. The strategies imposed are necessary in order to have an immediate significant decrease in emissions, as can be seen clearly by the reduction of about 80 gigatons of carbon in the atmosphere over the first 25-year cycle. Unavailable technology at this day will be important for the future strategies in order to continue the decrease. Once these rates have been implemented over the course of the next 100 years, further reduction in emission and fossil fuel production rates correlating to the integration of clean renewable energy can be applied to our system. And trees being planted cannot be increased due to the limitations of available land, especially with cutting trees at an all-time low. This goes the same with tilled land arriving at 0 hectares globally in year 2112. With that known, new policies and abatement strategies in the coming years are essential. In implementing these strategies, the most effective way to reach maximum efficiency in reducing atmospheric carbon will be achieved solely by global collective action.